So for this question, they want us uh, to find the current through the capacitor. So they've given us the voltage across it, and they've given us the capacitance. So if we want to find the current, we know we'll use the Ohm's law for phasors, and this is going to be voltage in phasor form divided by the impedance of the capacitor. So the first that we're going to get is going to be the impedance for the capacitor. The impedance here for a capacitor is 1 over J omega C. So this becomes 1 over, and then this will be J. Omega is 1 millifarad. So this is going to, no, omega is given in the question as, okay, we'll get it from the wave. That's a 314. Then the capacitor is the 1 millifarad. So it's going to be 1 by 10 to the minus 3. So here, this will become 1 over J. When you multiply this, you get 0.314. Then now we divide 1 divided by 0.314, and we get 3.18. When the J goes up, it becomes negative. So that becomes the impedance. Next, we want to change the voltage. It's 30 sine 314t plus 10. So I want to change it and express it in terms of cosine. So we use the double angle identity for cosine. We know cos A plus B is equals to cos A cos B minus sine A sine B. So we want this to remain as just sine that. We know the max is going to be 30. So if A is the current argument, which is 314t plus 10, what angle must we add? Phi, so that cos reduces to just sine of A. Initially, it's supposed to be cos of A, which is cos of 314t plus 10, and then cos of phi minus sine of A, 314t plus 10, and then sine of phi. But we only want this and positive to remain, meaning this first part must be 0. If the first part must be 0, then cos phi must be equals to 0. Secondly, the second part must be positive, meaning this negative shouldn't be there, and this sign should give us 1. So, meaning sine phi must get rid of a negative and should give us a 1. So it should give us -1. So the negative will get rid of that. We said there's only one angle which ensures that sine gives us -1. And sine will give us -1 when the angle is 270 or -90 degrees. So that's the angle that I'm going to work with. And notice that this -90 will also satisfy this condition. So what does this mean? It means that in cos form, this expression can be written as 30 cos 314t plus 10 minus 90. And when you rewrite, this is now 30 cos 314t minus 80. That's when you add these two. So if this is the expression as a sinusoidal waveform in terms of cosine, we can get the value now in phasor form. So in phasor form, the voltage across the capacitor is going to be the peak value 30, phase angle minus 80 degrees. So this is what we have. So to get the current now, as we wrote earlier, we're going to divide the voltage divided by the impedance. The voltage is 30, phase minus 80. The impedance, we had negative J, 3.1, 3.18. We want to divide these, but we can't divide the way it is. So we have to change the denominator and present it in polar as well. Currently, it is in rectangular. So seeing the way it is, it means that the real part here must have been 0. The y part is equal to minus 3.18. So that's the imaginary part. So the peak value is just x squared and then y squared. So you see that the peak value is going to be 318. Next, how about the angle? Sorry, the voltage. Oh yeah, the voltage does have a minus 80 there. At this point, you can even check to say that your answer, where it's going to be. Because you know, here, the magnitudes of the peak values are just going to divide. So already, you can even start seeing where your answer is. So that you know if you've made a mistake and need to revisit your work, or if you're on the right track. So I will divide 30 divided by our answer there. So when you divide 30 by the peak, we get 9.42 as the peak value. So 9.42 as the peak current. All we now need is the angle. So when I go back to the options, 9.42, do we have 9.42? We see that we have 9.42 here. We also have 9.42 here. So we now know that the peak current is 9.42. The only thing left is which version is correct. Are we going to go with the cos or with the sine? So let's proceed a little bit. So when you come back to our problem here, we know the 9.42 is correct, so we can continue confidently. If we found a different answer which is not among the options, we'd have to check our work to see if we made a mistake. But here, looks like we're fine. But let's see if we didn't make a mistake as well on the angles. So when you're trying to find the angle here, since the x part is 0 and x is the peak cos phi, it means that cos must have been equals to 0. For cos to be 0, phi has to be equals to 90, or it has to be equals to negative 90, which is basically 270. Let me say 270. Okay. On the other hand, for the real part, for the imaginary part, minus 3.18 has to be equals to the peak value, which is 3.18, and then you have sine phi. So meaning that sine phi has to be equals to negative 1. For sine phi to be negative 1, as we saw earlier, for sine phi to be equals to negative 1, phi has to be equals to 270 or minus 90, which is the same as 270. So that is what we're dealing with. Now, once we have our answer as our angle, so let's get this expression and try to complete it. So if we go with, we know this, our answer for the angle is this. Let's try to go with negative 90. If we go with negative 90 here, it means that when we say minus 80 minus 90, it becomes minus 80 plus 90, making this a 10 here. So if we did that, then our current in sinusoidal waveform would become IT. This would be 9.42, and then cos 314t plus 10. We don't have this among the options, so this one is not there. But let's try 270. So if we went with 270 here, what are we going to get? So if we went with 270 there and tried the same thing, that's 80. We'll likely end up with something similar, which is not there. So I have 80 minus 80 minus 270, which is going to be 350. So with that, IT will be equals to 9.42, and then cos 314t plus 350 degrees. So when we look at our options, the ones we have, since our peak has to be 9.42, the options that we have, none of them have that 10 degrees or the 3, that's 3 what? Or the 350 angle that we want. So what do we do here? So we want to check now, is it possible that maybe this was transformed one more time to maybe sine? Maybe it was written in terms of sine again. So let's try. So if it was transformed maybe to be written in terms of sine again, what would it be? So if I wanted to write this in terms of sine, so I'd get sine 314t plus 350. What angle must we add? Phi. So this would reduce to just cos. We know for sine, this would be sine A, which is sine 314t plus 50. And then cos B, so cos phi plus sine phi, which is sine B, and then cos A being 314t plus 350. Let me say 350. Let me start with using 10. Let me start with using 10. Okay. So from here, want this to reduce to just the cos version, meaning this version. So the first part should be 0. This should be 0, implying that cos phi has to be 0. If cos phi has to be 0, then the second part has to survive, so sine phi has to be equals to positive 1. So for sine phi to be 1, it means that phi has to be equals to 90. That's when sine phi will give us a positive 1. So with this done, we now see that we have sine 314t. So let me say, we now have our expression. I got the one with a 10, which is this. So just seen that this expression will be the same. The peak doesn't change here, so it will still be 9.42. But now we're writing it in terms of sine. Sine 314t plus, now we're adding a 90 to the argument, so it becomes plus 100 degrees. So this is what it would become.